14 of Coding Every Day. Today is January 29th, 2025 at 1:46 p.m. Today is a Wednesday. No classes today. Sorry. I have to close something. Okay. So yesterday I did lowest common ancestor binary search tree. And today I thought I'd take a break from the tree questions and go do a backtracking one. So I've done a couple here. I did subsets recently. I basically looked up the solution on how backtracking problems sort of work. So I'm going to try to take that knowledge and apply it to a new question I have not tried yet. So without further ado, let's begin combination sum. You are given an array of distinct integers num and a target integer target. Your task is to return a list of all unique combinations of num where the chosen numbers sum to target. The same number may be chosen from nums an unlimited number of times. Two combinations are the same if the frequency of each of the chosen numbers is the same. Let me reread that again. Two combinations are the same if a frequency of each of the chosen numbers is the same, otherwise they are different. Okay? You may return the combinations in any order, and the order in each numbers can be in any order. Okay, so the base case, all right. So for instance, if we have 2, 5, 6, 9. All right. So I'm thinking the base case is when your running sum is greater than the target, then you stop. Isn't this kind of like it kind of reminds me a little bit like coin change, in the sense like these are your coins and this is the value you want to get, except instead of returning the number of coins, we're returning the actual combinations themselves. Okay, so the way I guess I could look at this is, so you pick any number, so let's say 2, and then you can pick any number again. So, okay, so you start at your starting node, which is 0, and then you can pick either 2, 5, 6, or 9. And then from each one of these, so now you have a new sum. And then every step you check if it equals target. If it equals target, then you add it. And then from every one of these, you do the same thing. So you go 2, 5, 6, 9, like that, and you get 4, 7, 8, 11. And then from this one, 2, 5, 6, 9. So you get 7, 10, 11, and 5 plus 9 is 14. Okay, now from this one, 2, 5, 6, 9, you get 8, 11, 12, and 15. And then you get, well, actually, so from this one, you check if it equals 9, because that's a target, right? Yeah, target's 9. So because it equals 9, you just add it to the, you add it to the target. And I guess it's backtracking because we have to like go back and get the numbers that we added. Okay, so 9, we add it to the result. Okay. So 4 is good, 7's good, 8's good, this is not good, this is fine, this is... So anything that's greater than target gets canceled out. So all those get canceled. And then, of course, none of these will make it. It'll all go over. So the only one that I see... So 8s are dead. 7s are alive. So this will eventually lead to 9. Same with this one. And then 4... so if we expand 4, 2, 6, what was it, 2, 6, 7, 9? No, 2, 5, 6, 9. 5, 6, 9. We get 6, 9, 10, and 13. So here's another combination. So this one would be 2, 2, 5, and this one is 2, 5, 2. So okay, so we get 9, and then we get 2, 2. Sorry, we get 5, 2, 2. This one was 2, 5, 2, and this one is 2, 2, 5. So obviously in the problem, we only return one of them. So my initial thought would be just to have the answer as like a set, so we can't have duplicates, and then just turn it into a list at the end. And then maybe go from there. So that seems like what would be the simplest approach. Okay. So we want to say if, I'll say S is, I'll say total. So if total equals target, then return, so I guess I could say like, unique combinations. So combination, return combination. All right. So at every step, we want to say, so at every step, for instance, we look at this, we want to calculate, so we want to call DFS of total plus, I think what you would say is for num and nums, DFS total and plus num, DFS total plus, yeah, that's good. And we would say combination dot append num, and then what, combination dot pop. So this needs a number. So total. So maybe we say result dot append combination. All right. So in terms of actually tracing this, so let's see how this would work. So let's trace this code and see what it does. So we call DFS of 0. So total is not greater than target and does not equal target. So now for num in nums, and then we'll have combinations, empty list. So we append num. So num is 2. And then we call DFS of 2. And then that would say, okay. So num equals 2. And now we'd call DFS of that one. And that one would say, okay. So let's think. So it's going to add 2 and then call again with a total of 2. So DFS of 0 and now DFS of 2. And then DFS of 4. And then DFS of 6. DFS of 8. DFS of 10. Okay, so now when total equals 10, it's going to return. So if num okay, so let me see what this prints out. I'm not returning anything though. Return, what is it? A list of lists. Okay. So it's not printing anything. So is it not, it's not, maybe it's this part? Okay. Perfect. So I'll print total and combination. Yeah, so that looks good. All right, so let's see what happens after. Okay, this doesn't look terrible. So it goes to the 2s, and then after that returns, then it pops the 2 and adds a different num. So it tries 2225, 2226, 2229. Okay, and now when this fails, I don't really understand why that gets called. 2252, 2255, 2256, 2259, 226, 229, 25, 252, 2522. Okay. So it's a bit difficult for me to tell if all the combinations are actually getting tried. Okay, so result is completely empty. Okay, so let's try this. So if it equals 225, 252, 522. So it looks like it's finding it, but the problem is, oh, we have to append a copy of the list. Okay, so let's have res be a set, and then we will print list of res like that. There we go. You can't have a set of lists. Is that what it's telling me? Okay, so I'm just gonna do a little side thing and see. So if I have a set is 1, 2, 3, and a list is 4, 5, 6. What happens if I print list of a set? So I'm guessing this is not possible because it says, oh, no, it works. So okay, so that works, but if I were to try to turn a list into a set like this, then that will give me false, I see, right? No, okay, that also works. So let's see, so combination dot copy, I want to add that to a set. So, so if I have set 1 is an empty set, and I have list 1 equals 1, 2, 3, I can't say set 1 dot add list 1. So this will fail. Okay, so you can't add a list to a set because a list is not a hashable type. Okay. In this case, I could have combination be a set. Can you add a set into a set? Yeah, you could have a set of sets, right? So if I say set1 dot add a set, that works, right? Nope. So essentially the problem I'm running into is I need to just have a way to distinguish like 225 versus 522. So I could sort it. It seems a little clumsy, but I guess I could try it. There might be a better way to use like a hash map to or something to keep track of the uniqueness. Okay, so if I print, let me just make sure. So res, if I print res, that gets me what I want, right? Yeah, okay, so that gets me this. Which is right. All unique combinations. Okay, so maybe I can, so I think I have basically the problem. It would be nice to submit it. Let me see if the other test case is what we're expecting. SD out limit exceeded. Okay. Before I get too ahead of myself, let me look at every output here. So res 3334. I need one with 2 4s, 1 3, and 1 5. Right here. 4 4s right here. Okay, so it looks okay. So the algorithm is working. I just need to do this unique parts. So maybe there's a way. Hopefully I didn't delete that layer. Okay, so maybe there's a way I could store the path that I've taken. So maybe instead of appending it, I could insert it. So that way it'll always be sorted. Alternatively, I could keep a dictionary, or I could have some sort of mask, which is 0 times length of nums. And then whenever I add something, I can add so if I add like the nums of 1, I can say, so in this case, right, 0, so it'd be 0 0 0 0 because there's 4 nums. So if I added like in this case a 2, I could say 1 0 0 0. So it's basically like a count. If I added another 2, I could say equals 2 0 0 0. So that way I know. So if I have 2 2 5 and 2 5 2, they'll both have the same mask sort of thing. So it'd be 2 1 0 0. So they'll both have this. So I can check if this mask isn't in are combinations, then you can add you can add that. So I'd have to change this loop. So while I equals 0, while I is less than the length of nums, and then we want to I plus equals 1. So before I do anything, I just want to make sure it works with the while loop. Dot append nums of I. Looks good, looks good, looks good. Okay. So now what I can do is I could send a mask. Like this. You could say mask of I, so I'd say like mask. This might be more confusing than just sorting it, to be honest. But so yeah, I'll just let me try the sorting. Okay, so if combination okay, I'll say combination dot sort. Okay. So I have some extra combinations here, it looks like. So these two are correct. 3, 3, 4, 5. So these don't equal 16. I also am missing 444. I thought before when I had 4 num and nums. Maybe I should say this. Okay, so I have to sort it in place because this was messing up the other DFSs. Okay. So this is obviously pretty inefficient. More so than it should be. So let me see if I can improve it. So is there a better way than sorting it? The mask thing was basically just keeping track of every choice that you make. But maybe instead I can just put results instead of these. I can just have mask, and then at the end translate mask into a list. And this function gets called the most. So, okay, so I'm going to copy that and then comment that out. So for instance, if instead of appending well, I would need the total, but I would also do the mask. So then I would check if, so same thing, if the total is greater than target return, if the total equals target, and we could say if mask not in results, then add it. So results dot append mask. And then at the end we would have to say, so if I have a mask like 1, 2, 0, 3 for instance, to translate a mask into, so let's say the values were 2, 5, 6, 9, was it? Yeah. So then you'd iterate through each one. I think it would be n squared. Because you would say, yeah, it would be n squared to do that. Which I think is fine because this algorithm is b power, what is this one? So we're splitting in 4 every time. So instead of 2 power n, it would be like, it's not n power n, is it? It's the length of nums as your base, and then you split. It seems pretty slow, so I think n squared doesn't really matter. But usually a combination is pretty small anyway. Where does target? Target's 30. So the highest combination you could have actually is 30 length. So in that case, it actually is like kind of constant, because sorting an array of length 30, because all ones you could have, for instance. So sorting an array of length 30 doesn't actually matter at all. So I think it's totally fine. And this part is n as well. So if it's not in the results, so this is actually more costly, but I don't think I can have like, I think maybe results should be a dictionary. But to check if something's in a dictionary, is rough. I think I'm just gonna leave it like this. And let me see how my runtime compares to others. So LeetCode combination sum. I'm guessing it's gonna be pretty slow. Okay, it's very bad. Okay, well I'll call it here and then I'll do some research into how I can improve it. But I'm glad I was able to solve it. But yeah, I still should figure out how exactly I can avoid doing this. I'm guessing it has something to do with counting every time you make a move, and storing that somewhere in a dictionary or that mask thing I was talking about. So yeah, well that's it for today. I'll see you guys tomorrow.